Hello, welcome to the fourth video about the Pythagorean theorem. In this video, I will explain how to apply the Pythagorean theorem in 2 or 3 dimension objects. So after watching this video, you should be able to understand how to apply the Pythagorean theorem in 2 or 3 dimension objects. Okay, first in 2-dimension figures or objects. Look at this example. ABCD is a rectangle. The length of AB is equal 16 centimeter and the length of diagonal AC is equal 20 centimeter. Determine the length of BC, its perimeter and its area. Okay, to answer this question, first you should draw the rectangle ABCD. And then the length of AB is equal 16 centimeter. And then the second one, you should draw the diagonal AC. The length is equal 20 centimeter. Now you can calculate the length of BC. To calculate the length of BC, please consider the triangle ABC. It is a right triangle with B is the right angle. So AC is the hypotenuse and AB and BC are legs. So to calculate BC, we can use the Pythagorean theorem. Here, BC square is equal AC square minus AB square is equal 20 square minus 16 square is equal 400 minus 256 is equal 144. So BC is equal square root of 144 and the result is 12 centimeter. Okay, now let's answer the second question. Its perimeter. The perimeter of rectangle ABCD is equal AB plus BC plus CD plus AD or equal 2 times the length of AB plus 2 times the length of BC. We can write down here 2 times the length of AB plus 2 times the length of BC, or you can write like this. 2 times in the bracket AB plus BC. And then this equal 2 times 16 plus 12. 16 plus 12 is equal 28. So the result is 56 centimeter. Okay, now its area. The area of a rectangle is length times width. And the length is AB and the width is BC. So the area is equal AB times BC is equal 16 times 12 is equal 192 centimeter square. Okay, the second example. Look at these figures. The question is, determine the length of DC. To answer this question, there are 3 steps. The first step, you should determine the length of BC. And then the second step, you should determine the length of BD. And the last step, you can determine the length of DC. Now we will start to determine the length of BC. To determine the length of BC, please consider the triangle ABC. You cannot consider the triangle ADC because triangle ADC is not right triangle. So we cannot use the Pythagorean theorem. So please consider triangle ABC. It is a right triangle and B is the right angle. So AC is the hypotenuse while BC is the leg. So we can calculate the BC using the Pythagorean theorem. So BC square is equal AC square minus AB square equal 20 square minus 12 square is equal 400 minus 144 is equal 256. So BC is equal square root of 256 and the result is 16 centimeter. And then the second step, calculate the length of BD. To calculate the length of BD, please consider the triangle ABD. B is the right angle, so AD is the hypotenuse, while BD is the leg. So we use the Pythagorean theorem. So BD square is equal AD square minus AB square is equal 15 square minus 12 square is equal 225 minus 144 is equal 81. So BD is equal square root of 81 and the result is 9 centimeter. So now you know that the length of BC is equal 16 centimeter and the length of BD is equal 9 centimeter. Now what is the length of DC? Yes, good. The length of DC is equal the length of BC minus the length of BD. We get this. So it's equal 16 minus 9 and the result is 7 centimeter. Now I move to the second part, how to apply the Pythagorean theorem in three-dimensional figures or objects. Look at this example. PQRS TU VW is a cuboid. The length of PQ is equal 12 centimeter, QR is equal 9 centimeter and PT is equal 20 centimeter. Determine the length of QS and then the length of QW and the area of triangle WQS. Okay, look at this. The length of PQ is equal 12 centimeter. The length of QR is equal 9 centimeter. And the length of PT is equal 20 centimeter. Now, how to determine the length of QS? Okay, QS is called plane diagonal or side diagonal. So to determine the length of QS, please consider the triangle SPQ. It is a right triangle with P is the right angle. So QS is the hypotenuse. So we can use the Pythagorean theorem. And then the length of PS is equal the length of QR. So PS is equal 9 centimeter. So we get QS square is equal PS square plus PQ square is equal 9 square plus 12 square is equal 81 plus 144 is equal 225. So QS is equal square root of 225 and the result is 15 centimeter. Here is 15 centimeter. Now we will calculate the length of QW. Okay, QW is called the space diagonal. And to determine the length of WQ, consider the triangle WSQ. It is a right triangle with S is the right angle. So QW is the hypotenuse. Okay, we can use the Pythagorean theorem here. QW square is equal WS square plus SQ square. I repeat again, WQ square is equal WS square plus SQ square. Is equal here, look at this, WS and PT are equal. So the length of WS is equal 20 centimeter. So we get 20 square plus 15 square. So equal 400 plus 225 is equal 625. So WQ is equal square root of 625 is equal 25 centimeter. Now the last part, the area of triangle WQS. WQS is the right triangle. So the area of this triangle is a half times the base times the height. The base is SQ and the height is WS. So the area of this triangle is equal a half times QS times WS, or equal a half times 15 times 20 is equal 150 centimeter square. This is the use of the Pythagorean theorem in three-dimension object. Okay, for your task tomorrow, bring a 2 or 3-dimension object for tomorrow and discuss in your group how to apply the Pythagorean theorem in your objects. And then write down the result. After that, each group will exhibit their works to others group. I think it is clear. And then if you have free time, you can try to do this exercise. Okay, thank you for watching this video. See you tomorrow.